In this video, we're going to look at solving a logarithmic equation when there's a difference. So in this case, we need to condense this left-hand side to a single log before we can solve. Because they're both base 2, we can, and we have a property that says if we have the difference of two logs, it can be written as a quotient in a single log. So if you need to, go back and review our properties. So this can be rewritten as log base 2 of x over x minus 2. And that's equal to 3. Once we have it down to a single log, what we're going to do is we're going to rewrite it as an exponential. So 2 raised to the 3, that's our exponent, is equal to x over x minus 2, and now we no longer have the log. So what we have is that 8 equals x over x minus 2. Now the best way to solve this is going to be to get rid of that denominator. So basically we're going to cross multiply the x minus 2, or in other words multiply both sides by x minus 2. So we have 8 times the quantity x minus 2 equals x. So we have two x's in there and we need to solve for it, and we're going to do this all algebraically. So what we're going to do is we're going to distribute the 8. So we have 8x minus 16 equals x. Now what we're going to do is isolate the x, so let's subtract x off of both sides, and we'll add 16 to both sides. What we end up with is 7x equals 16, and our last step will be to divide both sides by 7, and so we end up with x equals 16 over 7. And it is a good habit to always check our answers because log does have a domain restriction. You can't take log as 0 or a negative number. So the domain of this first one is that x has to be greater than 0, which it is. The domain of the second one is that x has to be greater than 2. If you're not sure how I'm getting these domains, there's another video that shows how to find the domain of a logarithmic function. Well, 7 goes into 16 2 times plus a remainder of 2, so this is a little bit larger than 2. In fact, about 2/7 larger than 2. So this one is okay, and there's our solution for x.